You are listening to a piece of the Salasin.10 podcasterium.
And he is currently working with OCBC Bank, where he does his best to build the user-friendly banking apps. And Tor's talk will cover what that features a person should start learning in order to step into Flutter development. So let's give a round of applause to Tor today.
Good morning, everyone.
Morning.
Okay, so it's been a long time since my last event happened in here. But yeah, luckily my Facebook told me exactly 4 years ago I was here for DevFest 2018. Yeah, so and like reminiscing. And I'm Toru. I'm Wonyoung Choi, as known as Toru. Toru is my professionally looking for OCBC Bank as an Android developer in Singapore. And today I'm going to talk about not Flutter, purely Dart. I just started learning Dart and Flutter recently, so I just want to share some of my experiences while learning the Dart language. Okay, this is the official definition of Flutter. It is an open source framework by Google for building beautiful, natively compiled multi-platform applications from a single code base. Yes, that's quite interesting. It's quite surprising to create an app only on one single source code base. But this talk is not about Flutter. Because I just started learning Flutter, but I just want to highlight some features of Dart before stepping into the Flutter development. So today's agenda is four sessions: basic syntax, OP, FE, and asynchronous programming. I try my best to complete all the things in the time slot. Okay, hey, here, anyone used Flutter before? Wow. Yeah, it seems like you are more professional than me. Okay, don't judge me. Don't give me any score. Okay.
Yeah, but I didn't go to the session.
Okay, let me get started.
I can't remember what you talked about.
Dart provides this four fundamental data types in double, string, and boolean, but it doesn't have float, different from other things and different from other languages. And Flutter from Dart to Dart version, nullable and non-nullable has been added. So we can declare the variable as a nullable and assign a value as a null, or we can put it later if there's a null. Okay, so yes, of course, Dart also enables us to declare variable as an explicit type, but also enables us to give the type inferring. So we can use var or dynamic. So once we declare a variable like this, like the first example, speaker name is equal to Toru. But we can the value. But it must not be different from the previous type. So that means we cannot assign any other types other than like string. But dynamic is different. Dynamic is like a TypeScript, so we can assign any values, even we have once it defined. So we can choose. So we can put December as a month, but it's okay to put 12 as a month, and we can check the time. We can check the time of the page in one time. Okay, and of course that also provides a way to define the constant. So there are two ways: const or final. But in so-cons will be initialized during compile time. But by now we are initialized in runtime. So that means we cannot assign any values from a method, which will be run in the runtime for the cons. So there are some data structures like collections of map. So there are four fundamental things: list, set, and map. List like an array, so we can see easily. We can remove and add elements into list. And map is like a key and value. So we key and value data structure. So we can get this kind of example. But what happened at the last line? Okay, we can't know. And set is basically similar with the list, but one distinctly different thing is it doesn't allow us to put a deprecated value. So if I try to add Jisoo into Blackpink and try to print, it will be false. Because the add function basically returns Boolean type. So grouping condition is quite similar with Java. So I will elaborate here. So if else conditions or for loop and while and do while and switch by given value, or like enumeration is also possible. So here in the method Dart, quite interestingly, the parameters of Dart gives us some funny way to define the parameters. So this is the basic format of the method. So there are name parameters, or required parameter, or designated, or optional parameter. There are three kinds of things. So we can put the name of parameter explicitly in the method. So and this is required. That means compiler will give some error if we don't put any value. Pass any value to the parameter. And this is neither. So required parameters must be nullable or must have the default value. And this is a conventional way. And this is optional parameter. That means the second parameter will be optional. So it's not compulsory. Like this. It's also it should be also nullable or with default value. So I want to give some brief explanation regarding class in object-oriented programming. So this is a basic syntax of the class. So but here we can see there are multiple ways of how to define a constructor. There are default constructor or native constructor. But all the properties must be final. So and that doesn't provide any access modifiers. So in order to declare something declare this class as a private, we can just add underscore. And Dart also has also provides us how to build a custom getter or setter. Of course, we can access to the properties of the class, but this is the way to define the custom getter or setters. That keep in mind is different from consuming the method, but should be treated samely as as accessing parameters, like dot something equals something. Okay, this is inheritance. Inheritance, yeah, basically it's not classing. So so there are parents and children. So in the child class, we can use all the features of the parents class as well. But Dart. So this is an example of the inheritance. But interestingly, that doesn't provide any distinctive and explicit interface keyword. So if you want your class to work as an interface, you can define the abstract class like this and implement it. And basically classic Dart implements the defines interface internally. So you can implement any classes if you want to support other method in the other classes. Okay. So here I want to introduce some sort of functional programming features here. Like function can be treated as a first order object. It means pass as a parameter into the method. Can be returned as a function assigned to a variable. Let me show you the example at the next slide. So here, greeting is a method, and greeting2 is also a method, but it also accepts a callback function to return something back to the callee. So it can be assigned to the variable and can be returned. So we can transform the data structures like collection or maps into other forms using by consuming this to set or as map or to list.
No.
Here this is one of the example. So set can be generated from the set itself, or can be generated from the other data structures as well. And this is map. So by using map, we can transform the string into string or string into other data structures or customizable data structures as well. So there are two ways you can use mapping map has two parameters inside, key and value. So we can use this key and value into the map entry. Okay, this is where these next two functions are the examples of the functional programming in Dart. So where is like a filtering, returning some elements inside this data structure. So and it returns iterable. But iterable is like abstract, so it cannot be initiated. So I recommend you using this to list or to set or whatever functions to transform. Okay, reduce is like defining something, some calculations inside the brace. I showed a simple example. So so from the list with a 1, 3, 5, 7, 9. So if by using reduce, we can get the summation of the elements in the list. As everyone knows, there is a Dart pad. It's like online compile tool. So I just try to print out all the results. What's happening inside this brace. So So once the computation is done, the total can be the next group of the previous of the next group, and it iterating the loop inside. So finally, we can see the 25. And all the methods of the functional programming are cascadable. It can be appended after all the computations. Like this way. Yeah, we can map or take two and two list. So the final result is a list. Okay, fine. Okay, this is like a very fundamental things, features of Dart. And this is the last session of my talk, asynchronous programming. There are two kind of features, future and stream. But I want to cover only about the future and async and await. Future is like basically the values that will be returned in the future. Okay, give me 2 or 3 more minutes. Okay, but something. So once you call this function, then we can see the starts will be printed immediately and will be immediately. At last, we can see the total and total has just link. 2 seconds later, because I gave 2 seconds of delay. But sometimes we need to for this case, we can use async and await. So I just wrote the same function like this way, and we have async and await keyword. So async means this is a notifying compiler that this will be asynchronous. And await can be used for the functions that return the future. And the future is set, and main function is also a function, so we can put async. And the return type of feature speakers is also future, so we can add await keyword at the top, and we can see the result. So this is the example. So this is the result of this code snippet. So it looks like running the given code sequentially. And result. I ran 2 times. And this is like a wrap-up. But I don't think that my session, the features in my session is not everything in the start. So there are a lot of details I didn't cover. So I would like to highlight how could we use Dart in more Dart way. That's very important. Because there's no benefit when we use Dart or other functional programming language as in the same manner of using other languages like Java or other things. Okay, I want to wrap up again. I want to give a simple quiz. How many times Flutter appeared on this slide? Oh, raise your hand. Raise your hand. Raise your hand. There's a gift for you. Okay. No. And raise your hand. No. Okay, let me check.
Seriously? You really put the Flutter?
Oh, I thought it was this slide, that means that slide only.
3. Thank you. If you have any questions, please feel free to ask me any questions. I'll be around here. Thank you so much.
Sorry.
Accidentally to show me is a developer advocates for Google Cloud, and he helps to make learning, developing, deploying, and scaling applications on Google Cloud a delightful experience for everyone. In this workshop, sentiment analysts says with Google Cloud, throughout we introduce the concept of sentiment analysis and walk through almost so let us welcome Mr. Choi.
Thank you.
10 minutes.
And hopefully you get everything from that 5 hours workshop content in this 30 minutes. And we are a little bit over time, so just quickly go through this. So yeah, just a disclaimer, right? This is not the only way you can do Google Cloud sentiment analysis. There are a few other things that you can do, and you can create custom container, you can create using GKE, you can use Vertex AI, you can use language API and things like that. So don't take this as, oh, this is the only way. There's a lot of other ways. I just want to show you this because I spent like 3 days working on it. What is sentiment analysis? Anyone working with sentiment analysis here? Machine learning. Anyone working with machine learning? Few folks. Okay, so everyone's new to this, right? This is good, so that if I do something, you don't recognize. That's awesome. Awesome. Let's go. What sentiment analysis is all about, right? Imagine you have a board text, right? You're trying to analyze the text in a programmatically manner to understand whether that text is positive or negative. So that's what basically it is. So that I give you like, oh, you're awesome. That's sort of translate that sentence into a plus or minus number in your brain. You think there's a plus number, maybe a little bit tricky, but we will get there. So this is how it is. Right? So if you are thinking about positive spectrum, right? Like this is really great. Can't wait for the next one. If you're sort of neutral, you would think like, hey, it's okay, I guess. Right? Not much about it. How about negative? Before, so I hopefully this is how it right side, the left side is more the right side one. Right, so this is some example that you can sort of see, right? Like just from the text, your brain sort of translate into positive, negative, and neutral. So why is this important, right? So nowadays, everyone uses machine learning, everyone uses AI, right? You try to understand your market, right? How people are feeling about my product, right? How people are feeling about my company, right? You go and read about news, right? There's a lot of layoff happening in recent days. So this kind of sentiments is very hard for a human to read everything and you come up with a justification or whether it's a positive or negative. Right? But we can use machine learning to chunk off all these texts and then give you like a one single number, right? Which is really efficient and sort of, you can get some judgment based on that. And you can sort of see like, so what is sentiment about it? So this kind of topic, you can sort of do it using machine learning. And that's the beauty of it. You don't have to go and read and ask your friends about your opinion. So you just gather all the data, train the model, and the model will give you the results. So some of the use cases that involve, right, is like online review classification. So you can do review based, right, whether the reviews is positive or negative. The other is a stop price prediction. Don't go ahead and predict the price using this. If you lose some money, don't find me, okay? This is like guess, so it's not going to give you 100% accurate. So if your sentiment is positive, then you bet all your saving in it. You lost it, it's up to you. Don't do it. I say again, don't do it. You can also do social media analytics. So you want to know, whether the person has friend with positive influential people, negative influential, you can do that. So, and you can also do the student feedback classification, right? So if you're a teacher, you would like to know how my student think about my teaching, right? My courses, the university, right? So they will do this kind of analysis using sentiment analysis to do it. And also, of course, you can also summarize. So it's like dancing information down from like a set of text into a number, right? So you could do that kind of summarization. Okay, let's do a show of hands. So there are 6 sentences here. Who think the first one is positive? All right. How about the second one? Positive, negative, positive. Okay. Third one. Negative, positive. Can shout it out. It's okay. All negative. Fourth. Negative. Fifth one. Negative. How about 6? Neutral. Okay. You guys are almost right. So why I say almost right is what we do when we read these kind of sentences is by trying to pick up the keywords. So our brains are trained to do that, right? You tend to pick up some of the words that is positive connotation or negative connotation. And the sentence have a mix of those, right? You tend to think it's a neutral because you sort of balance it out, right? Like 1 + 1 - 1, 0 kind of thing. So that's how we are trained to do, right? But that's not always accurate sometimes. So what we do in that case, right, is actually is very primitive way to analyze sentiment analysis. It's called rule-based. So what you do, right, you try to stems it. The stem it means you try to change the form of the words into the base word. So it's like good become, best become good, and all this simplify all your vocabularies, right? Then you remove all the stock words like and is there, so that those words doesn't mean anything to the sentiment, right? Like an apple, 2 apples, is 3 apples. And also there's like some of the words that we have, like the negative words, we convert it. So it's like not good, we change to bad, so that all the words, right, with the not, we just convert it into the negative words. So now we have list of positive, list of negative, right? Then what we do is we try to have a dictionary of this, and then we assign the number to those. Then we calculate the positive or negative based on the calculation, right? So in this sentence, how many positive words are there? In this sentence, how many negative words are there? Then we try to see what's the end result, what's the value of it. So this is like really primitive way, which how we sort of perceived it. And if you realize, right, same sentence, same words, depends on which words you stress, it gives you different meaning. Like you can read from here, like I never said I do, like I never said it, someone might have said it, right? I never, so I didn't do it. I never said, I might have written it down. So it all depends on which words you stress to the pronunciation, right? It means different things. Even though they are same sentence, exact same words, depends on the stresses of the words, you will means different things. So how do we then use rule-based to analyze this? We can't do that, right? So there are some challenges tied to this kind of task. So this is something that we need to understand. So we try to progress further away from the rule-based, and what we do now is we tend to do machine learning approach. So machine learning, this is like a very standard machine learning practice or the workflow. You have the data set, right? And you have a pre-processing step where you try to clean your data, where you try to implement your data, augment your data, and things like that. After that, when you have the data fully already, you try to create feature out of features in the sense of signal from your data. You're trying to create signal from your data so that your machine learning models can pick up those signals to do some tasks, right? Be it classification, be it regularization, things like that. After that, we have 2 phases, model training and model inference, right? So model prediction. So you have a test data for prediction and then train data for training, right? So at the end of this workflow, you will receive like the model in the middle. Then you can use this to train, you can use this to predict. So if you realize models that we train in the current form, it only takes in numerical value because it's all formulation. Time this, time that. Okay? So how do we convert words that we write into digital format? Let's say hello world, we want to convert it to 0, 1, 0, something like that. So how do we do that? So people are trying to find out the ways that they can convert words into a meaningful, we we call it array or vectors or lists or matrices, depends on where you're coming from. And one of the ways that we can do is back-of-words approach. Anyone heard of back-of-words approach before? Yeah, a few. You want to explain? No, just kidding. Testing only. So this is a very simple example of back-of-words. Right, so we have three sentences here. Hello world, I like to learn new things, and learning make new things fun. The first thing first, how we do is to break it up into single words, right? And we have an array of those words. From sentences, break down into words, put them into an array. Okay? The next step, right? We combine those into one thing. So far, so good. So once we combine, right, if you realize there are some things, there are multiples of the same words, right? So we don't need to keep them because they are the same. So we find a unique one. And there's another one which is like learn and learning. They pretty much mean the same thing, but for the simplicity's sake, we're not going to do anything about this for now. We just keep it as it is. Right, so now we have, from the sentences, now we have this thing called vocabulary. Right, so we have all the list, or the unit words from those sentences that we do. Then we build a matrix. So matrix, right, is you put in all the words from the right side and your sentences on the left. First thing you do is to put 1 at every single word that contains in the sentence. Right, so hello world has one hello, one world, right? I like to learn new things like one I, one learn, one like, things like that. So once you fill out these ones, the remaining things you just fill out with 0. So once you do that, you have a vector representation of words, or the sentence, right? So if you say hello world, it translates to 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 1, and so on. So now I have a question for you. If I have hello, hello world, what my vector will be? Anyone? I have one source from last time. Yes, I can give out this. Oh yes! 0, 1. You mean it's the same as the first one? Sorry. Anyone else? All zeros. No. Had to be some 1 there, right? All 0 means 10. Yes. We will check those. 0, 2. Yes, you're right. So okay. Why do you say 0, 2? If you can say it, I can give. 2 hello. That's very simple. So imagine this, right? Whoever, right? If someone come and tell you, I like you versus I really, 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 really like you, is that a difference? No? Who said no?
There's a weight difference.
You take it from me later. Yeah, so the more words you put into it, the emphasis, right? It sort of change the meanings and the sentiments. Maybe not so much into like changing from negative to positive, but it reinforces some of the words that you want to try to say, right? Like I like you versus I really like you, that really sort of emphasize it. So it's slightly different because this is very simple sort of problem that we're trying to solve. But when you try to do complicated one with like a spectrum of sentiments, right? Then those words really come into play, right? So you really, right? And some words that emphasize it, I like you more, right? So those are some words that we should capture. Right? So in this simple case, because there's 2 hello, just do 2. So it's to differentiate between hello world versus hello world. Okay, so now that we have created a feature, so we know ways that we can convert the sentences into vector and matrices. All we need to do is start training model, right? So one thing that I want to talk about today is BigQuery. So why I'm talking about BigQuery is that I was trying to do this using Python. So anyone know Python here? A lot of people, right? Anyone who doesn't know Python? Yes, for you guys. Because my friends keep asking me, hey, do I need Python to do machine learning? Do I need that? Okay, let me try to find whether I can do something without using Python at all. So I tried to find a way, then I found it. It's this BigQuery. So BigQuery is like database, but they split into two parts. One is computation, the other is storage. So if you are only computing, you don't have to pay for the storage. If you're just storing, you have to pay for the computation. And they have like very big distributed memory buffer to just keep communicating to each other. So it also works for streaming, it also works for batch. So it's like everything about inside this whole warehouse. Right. So I was like, oh, this looks interesting, and it supports machine learning. So the syntax look exactly like SQL, right? You have like select statement, you have like where clause and from clause and things like that. And then what it does, right, it runs distribute manners. So you process like 500 plus gigabyte in like 5 seconds. So it's really fast. But the downside is that if you do it incorrectly, it's going to read a lot of data. So you have to sort of know what you want, and you have to filter it from your query so that you don't incorrect unnecessary costs. So, and BigQuery comes with BigQuery ML. Right, so BigQuery ML, it looks like this. So create model, then a model name, then your data, options, and things like that. So once you do that, it will use that distributed way to train the model for you. So you don't have to use, let's say, scikit-learn or like Keras or things like that from Python library, because it natively let you train model on SQL. And like we're expanding a lot of support for this. So if you are, let's say, just use normal ones, right? Like linear regression or discrete regression, we support that. But we also support things like K-means, we also see like HGBoost, right? Auto MLs, like deep neural network. You can train those models using SQL now. Right? You don't have to go and pick up Python for data science. Because if you already know SQL, you can do it now, right? So this is what I try to do. So let's go to GitHub. Okay, guys. I have a few more minutes. So I'm making 15 minutes. Nice. Okay, then we can finish everything. So far, so good. Any question before we go to that? All good. If not good, then let's see. Right, so okay, so this is the repo that I just created, or I created a few days ago. As you can see, it's only like 21 days old. So from here, right, what I have is I have this. So this was a workshop, so I just dumped it down into talks. So there's a lot of like hands-on exercises that I asked the audience to do. If you don't want to do go for lunch, you can sit down, I can do it for you. But I would prefer you go to lunch. Right? So there's like, the first thing first, right, I want to do machine learning. I know Python, so I started using Python, right? So I git clone it, and then, let me just zoom it in again. Yeah, so this is Jupyter Notebook. I git clone it in my PyCharm, so everything that I have is here. I just use Jupyter Notebook to use it, right? So I have the data. I use Python to train the scientific analysis model. So let's go back. So to do that, I need to create a credential because my data are stored in BigQuery. Right? So how I create credential? I just come here, click create credential, service account, blah blah blah. I got a service account. I go in, I get a key. Right? So the key is here. I get a key, and then I put the key inside my here. So this is my key. Sorry. So don't lose your key. If you lost your key, people use your key, and then you get charged. Okay. So don't lose it. I'm going to delete it later, so it's okay. So for now, I'm just assigning my keys, and then I use the keys to communicate to the cloud. Right? So I don't store data on my physical device. I just read directly from the cloud. So the first thing first, I'm just loading my BigQuery extension. Right? Then I use SQL statement using this magic function called BigQuery on Jupyter Notebook. Once I do select this, select that, right? You can actually download all this data, and then it shows you exactly what your data looks like. So in this case, I have like a review, and then I have like a label, right? So this review has negative label, this review has positive label. So if you want to store those results, so currently it's not storing anywhere, you just query. But if you want to store it into a data frame, for example, you could just use BigQuery and then put your data frame name at the back. So it's like train df, and then when I execute this query, the train df will have a pandas data frame with the data that you query. So you don't have to write custom Python to do it. Then now you have this clean data set. I just check the shape of it, right? I have 2 columns, 24,000 rows. Try to find any missing value in it. Try to describe whether I have a unit value, what's the frequency, and so on. And then I also find the distribution of my labels, positive and negative. So they are sort of balanced. So we can do it machine learning in a safer manner because they are balanced. So now we have to find the test data. Same way, we have test data, right? We query it, put into a test data frame, do some simple analysis to figure out whether we are doing correctly or not. Then, to training model part, right? Python is very straightforward. All you have to do is just import scikit-learn, linear model, and then you have a feature extraction of vector counter. So count vectorizer is back or works at the back. So when you put in the sentences, it will give you the code. So when you run it, right, what I do, I initialize the count vectorizer here with my token patterns of anything more than 2 characters. I just take it as 1 word. Then I do a fit transform. This is to build up the vector. Remember the tables that we just drew, like 0, 1, and all this. So we are building up this. And then I just apply negative to 0, positive to 1, because we are working with numbers here. We do the same thing, but for test data, I'm not training I'm not building the vocabulary, the vector anymore, because I just use whatever, and then if I don't find the words, I just put 0. So this is how the whole vector looks like. Right? So you can see there's a lot of work and S work, but it's like mostly 0, right? Because some of the sentences only have 1 word, maybe a few words, then you have 1. The rest are all 0. So we use this matrix, we call it matrix. Just train logistic regression over here. Right? I'm putting max iter of 1000, so I don't want to just keep on running forever. Once I train, I try to predict the test data set and measure the accuracy. So I managed to get 86% accuracy using whatever I just written here. So you can spin off this in like 10 minutes, right? Just import this, copy this code from somewhere, dump it here. So I was like, this is too easy, right? This is not how we do things. We have to make it a little bit difficult and interesting. So what I do, I totally don't use Python to do this kind of task again. So what I did was I tried to write SQL code to translate all the Python code that written there into SQL code. So let's see, we still have time. So first thing first, I create a schema, right? So if you are from SQL background, this is very SQL based kind of thing. After that, I create a table with the review. Let's see, yep. So this is to get my reviews, and then I'm extracting the same way using the regex, and get the lowercase character separate into words, and then count the row number. So the results looks like the process review. See, review. So every single sentences is broken down into words. Like every single words is here, and then of course they are labeled, right? So the sentences are no longer sentences; it breaks down into array. So like all the words have individual items in the array. Right? So once I've done it, I need to create the vocabulary. So in this case, I'm only selecting top to 20K. So this is how it is done. You can go and see the code. It's quite interesting because I have to do a lot of nesting query to get all the things I want. This is how it looks like. So finish already. Good. Oh, yeah. But later I can do it. So this is how the vocabulary that we built looks like. So different words have the frequency and the index in the whole list of the array. So for this case, so have 20k plus frequency, but it should be at the index of 32. So the rest is 0. If your sentence is just so, right? Everything else is 0, then index 32 will be 2536. Remember the hello words? We have to count the number of words. So this is how the number works. So once we have this, okay, and we move on to merge them back. It's like feature engineering. So we do the aggregation, we try to merge. It's quite hard to explain at the moment because it's a lot of words. But it sort of creates something like this. So once you run this code, right, you will see review number has these words, but instead of just words, you have the index and then the frequency. And whichever index not available in this sentence, we just take it as 0. Okay, so let's say the index starts from 0 all the way to 23. Everything will be 0. Then index 23 will be 27657. That's how we store it in BigQuery. And then we just train the model. So once we have all the features, right, I train the model using this. So it's create, replace model. In this case, I'm using logistic regression classifier because we are doing a classification task, differentiating between 1 and 0. So I say logistic regression, I'm going to use auto split to split my data. I'm going to have a label and I only train for 3 iterations because it's going to distribute a lot, so I don't need to train as many frequency as I need. Then I just have to pass in my features number, the labels, and then which table I'm reading the data from. So once we do that, we have a model. So the models will be built this way. So this is the model that we just built here. So what it gives you, right, it's not only the model files, it also gives you everything like evaluation criteria. So evaluation criteria is what's the precision, what's the recall, what's the accuracy, what's ROC curve, and it also gives you some diagram here. So if you are in like stats or machine learning background, you're probably familiar with all this like precision recall curve, F1 curve, and ROC curve. So all these things is built in. You don't have to build it yourself. Right? So once you train the model using BigQuery, it comes together with the model. Right? So you don't have to go to like build a dashboard just to monitor this thing. It's come together. So once we have it, just going back to the SQL, we have evaluated, right? Then we train the model, we test the model. Then once we have the model, we have to test it with the real world data, right? So if we can put in some text here, and if the model can sort of differentiate whether there is positive or negative, we have done our job. If not, there's no way to test, right? Because all the data are there, you just train it and you just use it, and then if you cannot use in real life, it's no point, right? So this is what I did. I create a user-defined reviews. So can't wait for the new one. I don't like this one. The best is to come. So who thinks the first one is positive? Second one is negative, positive, negative. The third one, positive, right? So if we run this, let's see, it should give us like evaluate the train model. Okay. So the good thing about BigQuery is when you run using a selector, right, it's only run the code text. So even if I run this now, it will only run the code text. It won't run the code text. So you can see it here. It's negative, negative, and positive. I don't know why. Let's see. Can't wait for the new one. Maybe because of the word can't. Let's give it something. Anyone? What is that? I'm excited to leave. Oh, no. Let's see. Okay. The first one, right? Is negative. Anyone?
That one sounds like it's the negative.
Henry positive. You know why? Because they need to lose weight. Just kidding. Henry is positive because you are still Henry. Henry for knowledge. Henry for some PR answer. So in case someone finds it later. So yes. So this is pretty much what I have to share.
Maybe because the
So let's see whether I have
probability
more slides.
center.
And we made it in time, so thanks so much. And now, if you want to stay connected, right, you can scan this QR code, add me on LinkedIn. I'm almost there all the time. Just don't tell my manager.
Thank you, Daya. So now it's lunchtime, but before we leave, I just want to mention, because I forgot just now, we will have lucky draw.
That was a piece of the Salasin.10 podcasterium. It is hoped that you have enjoyed it. If you have any issues, please feel free to leave a comment through any of the channels.